Welcome to Physics Trek. I'm Alan J, here with another worked solution to help you improve your physics and to show you best practice in answering questions. So let's get started. In some respects, this is a straightforward question. It only uses one equation of motion. However, the difficulty is in visualizing what is asked for. A clear diagram is therefore essential to the solution. Anyway, here is our question. Question 6. A train, 90 meters long, stops in a station with its front buffers in line with a lamppost on the platform. Later, the train starts off with an average acceleration of 0.45 meters per second. What will be its speed in kilometers per hour when the tail buffers pass the lamppost? Answer to 2 decimal places. So here are the equations of motion and their quantities in blue down the side for quick reference. And analysing the equation, writing out the information given in symbol form, we have A is equal to 0.45 meters per second, S, the distance, is equal to 90 meters, U, original velocity, is 0 meters per second, and we need to find velocity v. And now to the diagram. To start with, we put 2 arrows with vertically dashed lines below to show the original position of the train, and a further dashed line to show the final position. We draw in the train and shade it, put in the lamppost and the buffers, and the train as the buffers clear the lamppost. Okay, I'll just draw the tail buffers. Now the distance we require is the distance the rear buffers move from the start of the acceleration to the end. So the distance s is 90 meters. U is equal to 0 meters per second. V we need to calculate. The acceleration over the 90 meters is a, which is 0.45 meters per second. So before we go on, for a few seconds, have a close look at the diagram and appreciate how it pictorially describes the question. And now for the calculation. We need V, have A, S and U, so the obvious choice is V squared minus U squared equals 2AS. But we need to make V the subject of the equation. First we take U squared over to the right and change its sign, leaving V squared on the left on its own. Then we simply take the square root of each side, so V is equal to the square root of 2AS plus U squared. And now substituting the numbers, V is equal to 2 times 0.45 times 90 minus 0 squared, square root of, which is equal to 0.9 times 90, square root of, 0.9 times 90 gives us 81. Square root of 81 is 9. So V is 9 meters per second. Now then, we need to convert this meters per second to kilometers per hour. We do that simply by dividing by 1,000 and multiplying by 3,600, which is the same as multiplying by 3.6. So in kilometers per hour, V is equal to 9 times 3.6, which gives us 32.4 kilometers per hour. So here is our answer. The speed of the train when the tail buffers pass the lamppost is 32.40 kilometers per hour. That's to 2 decimal places. And that's all for now. I hope this video has helped you out. Do look out for more worked solutions on the topic equations of motion, more coming soon. Anyway, Thank you all for watching. Please do subscribe to the channel and be the first to see all the latest releases.